And now in this lecture we'll answer two questions. In the first question we find out the height of this right triangle ABC, that is to say the length of side AB. And in the second question we find out the area of this square ABCD, and we also find out the length of this tangent PQ. So we start with the first question. In the drawing we have the right triangle ABC. Angle ABC equals to 90 degrees in size. BC equals to 4 units in its length, and the radius of this circle equals to 4. So we have a circle that is inscribed by this triangle ABC. BC equals to 40. The radius of this circle is 4. And our task is to find out the length of this side AB. This is actually the height of this triangle ABC. If the base is BC, then the height is AB, that is defined as h. So we have to find out the length of AB that equals to h. So first of all, we will define the relevant points to this question with letters. We will define the center of this circle. This point is point O. Likewise, we will define the point of tendency of tangent BC with this circle. This point is point E. We define the point of tendency of tangent AB with this circle. This point is point F. And we will define the point of tendency of tangent AC with this circle. This point is point G. In the next step, we will join points O and D together by a straight line. Point O is the center of this circle. Point E is the point of the circle itself. Therefore, OE is the radius of this circle. That is equal to 4. Here we can implement rule 1. The radius OE is equals to 4. The radius OE is drawn to point E. That is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees, according to rule 1. Likewise, we join points O and F together by a straight line. OF is of course the radius of this circle, equals to 4. The radius OF is equals to 4. The radius OF is drawn to point F, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius F4. If AB is perpendicular to F4, it means that this angle equals to 90 degrees in its size. This angle also equals to 90 degrees. According to the same rule, all 1. So, inside the small quadrangle FOEB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth facing angle, in total must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees, and therefore this fourth facing angle must be equal to 90 degrees in its size. So inside quadrangle FOEB we have 4 right angles, therefore we can relate to quadrangle FOEB is rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in rectangle FOEB, side FO must be equal to the opposite side BE, but FO is 4, therefore the opposite side EB must be also equal to 4 units in its length. Likewise, according to the same rule, in the same rectangle FOEB, side OE must be equal to the opposite side FB, but OE is 4, therefore the opposite side FB must be also equal to 4 units in its length. So in total we found out that the small quadrilateral FOEB is not a heptagon but a square, why? Because of the fact that all of its sides are equal to each other, each side equals to 4 units in its length. What is the length of this? This is 97 EC. EC equals to BE. EC equals to BC minus BE. So no, the missing 97 EC is equal to BC minus BE. So EC in total equals to BC. BC is 40 according to what is given in the question. Minus BE, B equals to 4. So in total we found out that the missing tangent EC is equal to 40 minus 4 is 36. EC equals to 36 units in its length. This is tangent EC is equal to 36 units in its length. In the next step, we will implement rule 2 in our drawing. So I'll click on rule 2. According to rule 2, the lengths of two tangents from a common point to a circle are equal. So in the drawing, we have a circle. This is the common point P. From this common external point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is, according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can implement rule 2 in our drawing. Well, in our drawing, we focus on this common point C. From this common point C, we have two tangents to this circle, tangent CE and tangent CG. And according to rule 2, they are equal to each other. This is to say, CE equals to CG. But C equals to 36, therefore CG must be also equal to 36 units in its length. Likewise, we implement rule 2 at point A, this comes from point A. On this comes from point A, we have two tangents to this circle, tangent AF and tangent AG. According to rule 2, they are equal to each other. That is to say, AF equals to AG. So if we define the length of AF as x, then AG must be also equal to x units in its length. In the next step, we will implement the Pythagoras theorem on this big right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, the right big triangle ABC, here by PT is the ratio for Pythagoras theorem. So according to the Pythagoras theorem, in this big right triangle ABC, the following equation is true. AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. Okay, again, this right triangle ABC, according to the Pythagoras theorem, AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. AC in total equals to x plus 36. Therefore, AC squared is x plus 36 squared. And it is equals to AB squared. AB equals to x plus 4, therefore AB square is x plus 4 squared. Plus BC squared. BC is 40, therefore BC squared is 40 squared, that is 1600. So in total, if you found out that x plus 36 squared equals to x plus 4 squared plus 1600. Here we will open the brackets on both sides of this equation, and we get that x plus 36 squared equals to x squared plus 36 squared, that is 1296, plus 2 times x times 36, that is 72x, and it equals to x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x, plus 1600. So in total, we found out that x squared plus 1296 plus 72x equals to x squared plus 16 plus 8x plus 1600. Here we have x squared on both sides of this equation, so x squared gets cancelled. After cancelled x squared, in this side of the equation we left with 1296 plus 72x equals to, in the other side of the equation we have 16 plus 1600 is 1616 plus 8x. So here we subtract 8x from this equation. So here 8x will get cancelled, while on the other side we're left only with 1616. While on the other side of the equation we have 72x minus 8x is 64x plus 1296. So in total, we actually found out that 1296 plus 64x equals to 1616. So here we will subtract 1296 from this equation. So here 1296 will get cancelled, and we're left only with 64x equals to 1616 minus 1296 equals to 320. So in total we found out that 64x equals to 320. Here we divide this equation by 64. And finally get that x equals to 320 over 64 is 5. So x equals to 5 units in its length. Our task is to find out the height AB of this right triangle ABC. AB in total equals to AF plus FB. So AB in total equals to AF, that is x, plus FB, that is 4. So AB equals to x plus 4. But x is 5, so AB equals to 5 plus 4, that is 9. So then we found out that the height AB, the height edge of the rectangle ABC is equal to 9 units in its length. And again we found out that the height edge of the height AB is equal to edge of this rectangle ABC is equal to 9 units in its length. So we finished to answer on the first question. In the next step I present you the second question. Answer on the second question of this lecture. in the second question, our task is to find out the area of this square ABCD, and also have to find out the length of this tangent QP. So in the drawing, we have a semicircle and a quarter circle inside this square ABCD. This is tangent QP, that is a common tangent to both the semicircle and the quarter circle. So tangent QP is a tangent to those semicircle and quarter circle at this point. So we define the point of tendency of tangent PQ with those semicircle and the quarter circle. This point is point K. It is given us a question that the radius of this semicircle is 17. So we define the center of this semicircle. This point is point O. The radius of AO is 17. The radius, we define this point as point Z. The radius OZ also equals to 17 units in its length. We define the length of this line segment ZB as X. We define this point as point L, and we define the length of the short line segment BL as Y. It is given us a question that the radius of this quarter circle equals to 36 units in itself. So OL is the radius of this quarter circle, that is 36. So in the first part, we have to find out the area of this square ABCD. So what is the area of this square ABCD? We know that the area of any square equals to the length of one side squared. And again, the area of any square equals to the length of one side squared. So we choose AB as the one side of this square ABCD. Therefore, the area must be equal to AB squared. And again, the area of this square ABCD equal to the length of one side squared. That is to say, it is AB squared. AB in total equals to 17 plus 17, that is 34 plus X. Total AB equals to 34 plus X. So you substitute AB by 34 plus X. And we have to square it. So in total, according to equation 1, we have to find out that the area of square ABCD is equal to 34 plus X squared. We calculate the area of this square ABCD in another way. We just choose the side BD. We get that the area of square ABCD according to the second method of calculation is equal to BD squared. The length of one side squared. It is actually BD squared. BD in total equals to Y plus 36. Therefore, BD square must be equal to y plus 36 square. So if we found out that the area of the same square ABCD according to the second method of calculation equals to y plus 36 square. So actually we have two different equations for the area of square ABCD, equation 1 and equation 2. Therefore, we will create equation 3 that states that the area of square ABCD, according to the first method of calculation, must be equal to the area of the same square ABCD according to the second method of calculation. Very simple equation. So the area of square ABCD according to the first method of calculation is equal to 34 plus x squared. It must be equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the second method of calculation equals to y plus 36 square. So if you found out that according to equation 3, 34 plus x squared equals to y plus 36 square. So here take out all of the equation and find that here the root cancels the square and we're left only with 34 plus x equals to, again, the root cancels the square and we're left only with y plus 36. So total according to equation 3, we found out that 34 plus x equals to y plus 36. Here we subtract 34 from the equation. So here 34 will get cancelled. We left on this side of the equation only with x. And on the other side of the equation we have y, and 36 plus 34 is 2. So it is y plus 2. So in total we found out that x equals to y plus 2. X equals to y plus 2. Here we can implement all 10. Whenever you have an external knot between a semicircle and a quarter circle, you can implement all 10. So repeat quickly on all 10. According to all 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching points. So in the drawing, we have those two circles that touch each other externally at point P. The center of this circle is there at point O. The center of this circle is there at point M. The straight line that connects the circles together is of course the straight line OM. And according to this rule 10, the straight line OM must pass through point P, this is their touching point. Again, the straight line OM must pass through their touching point, that is point P. Or OPM is one straight line. Again, OPM is one straight line according to this rule 10. If OPM is one straight line, it means that OM in total must be equal to OP plus PM. we can implement rule 10 in our drawing. One because in our drawing, we have an acceleration between the semicircle and the quarter circle at point K. The center of this semicircle is 0.0. The center of this quarter circle is 0.0. The straight line that connects the circles together is of course the straight line this is point D. This is point D. Again, the center of this semicircle is 0.0. The center of this quarter circle is at point D. The straight line that connects the circles together is of course the straight line OD. And according to rule 10, the straight line OD must pass from point K, that is the touching point. Again, the straight line OD must pass from point K, that is the touching point. Or OKD is one straight line. Again, according to rule 10, OKD is one straight line. So we join points O and D together by straight line, and according to rule 10, the straight line OD must pass through the touching point, that is point K. You can see that indeed the straight line OD passes through point K, that is the touching point, exactly like rule 10. OK is the radius of this semicircle, that is 17. Likewise, KD is the radius of this quarter circle, that is 36. And according to rule 10, OD equals to OK plus KD. Again, because of the fact that OKD is one straight line, means that OD in total equals to OK plus KD. OK is 17, KD is 36, so 17 plus 36 is 53. So OK equals to 53 units in its length according to rule 10. So this is for ABCD. Therefore this angle is a right angle. So in the next step, we will implement the Pythagoras theorem on this main triangle OBD. We already found out that the hypotenuse of this right triangle OBD, the hypotenuse OD is 53 units, equals to 53 units answer. OB equals to 17 plus x, BD equals to y plus 36. So we implement the Pythagoras theorem on this green triangle, green right triangle OBD. Here by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in this right triangle OBD, it means that OD squared, that is the square of the hypotenuse, equals to OB square plus BD square. And again, according to the Pythagoras theorem, this kind of triangle OBD, the following equation is true. OD squared, that is the square of the hypotenuse, equals to OB squared plus BD squared. OD is 53, therefore OD squared is 53 squared. 53 squared equals to 2,809. and is equal to OB square. OB in total is x plus 17, therefore OB square is x plus 17 square. Plus BD square. BD in total equals to y plus 36, therefore BD square equals to y plus 36 square. So in total we will know that 2809 equals to x plus 17 square plus y plus 36 square. We already found out that x equals to y plus 2. X equals to y plus 2. So we can substitute x in this equation by y plus 2 and get that 2809 equals to x plus 17. So substitute x by y plus 2, so it is y plus 2 plus 17. So it is y plus 17 plus 2 is 19. So in total, its expression equals to y plus 19 square. We just substitute x by y plus 2. In total, this expression equals to y plus 19 square. And we have also here y plus 36 square. So in total, we shall know that 2809 equals to y plus 19 square plus y plus 36 square. Here we'll open the brackets on this side of this equation and you get that 2809 equals to y plus 19 square. Y plus 19 square equals to y square plus 19 square is actually 361. Plus 2 times y times 19 is actually plus 38y. And also here y plus 36 square. Y plus 36 square equals to y square plus 36 square. 36 square equals to 1296 plus 2 times y times 36 is actually plus 72y. So now we found out that 2809 equals to y squared plus 361 plus 38y plus y squared plus 1296 plus 72y. So we have here 2809 instead of the equation we have 2809 equals to y squared plus y squared is 2y squared We have 361 plus 1296. Uh, 361 plus 1296 is equal to 1657. We have also 38y plus 72y equals to 110y. So today we found out that 2809 equals to 2y squared plus 1657 plus 110y. So here we subtract 2809 from this equation. So in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 2y squared plus 110y. We have 1657 minus 2809 equals to minus 1152. So in total we found out that 2y squared plus 110y minus 1152 equals to 0. So here we divide this equation by 2. You get that y squared over 2 is y squared. We have 110y over 2 is 55y. We have also minus 1152 over 2. Equals to minus 576. And 0 over 2 is 0. So in total we found out that y squared plus 55y minus 576 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. A, b, and c are the coefficients of this quadratic equation. And x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0. could be this quadratic equation here. This y squared plus 55y minus 576 equals to 0. The variable that we are looking for is y, therefore x equals to y. The coefficient a equals to 1. Likewise, the coefficient b equals to 55. And finally, the coefficient c equals to minus 576. So we have all the data that is needed in order to find out the value of y. We just have to put the data inside this formula for x, and this way we find out the value of the values of y, because y could have two solutions. So we do it now and get that we have here x, so x equals to y, so instead of x by y equals to minus b. The coefficient b equals to 55, therefore minus b is minus 55 plus minus square root of b squared. B is 55, therefore b squared is 55 squared minus 4 times a. So it is minus 4 times 1, that is minus 4 times c. So it is minus 4 times minus 576. Divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total, we found out that y equals to minus 55 plus minus, and we have here inside the root we have 55 square. 55 square equals to 3025. We have also minus 4 times minus 576 equals to plus 2304 divided by 2. So we found out in total that y equals to minus 55 plus minus. Inside the root we have 3025 plus 2304. In total it is equal to 5329 divided by 2. So in total we found out that y equals to minus 55 plus minus the square root of 5329 is 73 divided by 2. So here we have two solutions that are possible for y. We just take the positive solution and we ignore the negative solution because y is an f, and as an f it must be a positive number. Y is the length of this short line segment BL, so it must be a positive number. So the positive solution for y is as follows. Y equals to minus 55 plus 73 over 2. Minus 55 plus 73 is 18, and 18 over 2 is 9. So in total we found out that y equals to 9 units in its length. But we already found out that y equals to x equals to y plus 2. X equals to y plus 2. X equals to y plus 2. That is to say, x equals to y, and y is 9, so it is 9 plus 2. x equals to 9 plus 2, that is 11. So today we found out that x equals to 11 and y equals to 9. The first part of the we have to find out the area of this square ABCD. So what is the area of square ABCD? Actually, we know that the area of any square equals to the length of one side squared. We choose the side of this square as AB, so it is AB squared. But we already found out that AB in total equals to 34 plus x. Therefore, AB squared must be equal to 34 plus x squared. But x is 11. We found out that x equals to 11 units in itself. So we can substitute x by 11. So in total, 34 plus x is 34 plus 11 squared. 34 plus 11 is 45. So this is 45 squared. 45 squared is 2025. So in total we found out that the area of square ABCD is equal to 2025 square units in size. And again, in total we found out that the area of this square ABCD, that is the area that we are working for this question, is equal to 2025 square units in size. So we finish with the first part. The question has also the second part. In the second part, we have to find out the length of this tangent QP. Tangent QP is a common tangent that belongs to both the semicircle and the quarter circle. So what is the length of tangent PQ? First of all, in order to find out the length of this tangent QP, we define this angle BDO as alpha. PQ is a tangent to the quarter circle at point K. DK is of course the radius of this quarter circle. The radius dk is equal to 36, the radius dk is drawn to point K, that is the point of tendency of tangent PQ with this quarter circle. Whenever your radius is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius KD. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees in its size. And this angle also equals to 90 degrees in its size according to rule 1. So, in the drawing you have the green small right angle QKD. This small green right angle QKD, this angle equals to alpha. This angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. So in the big right angle the big right triangle OBD, this angle equals to alpha. This angle equals to 90 degrees, therefore this first angle must be equal to 90 degrees minus alpha. According to the sum rule, that says that the sum of the angles in any triangle is equal to 180 degrees. So this first angle must be equal to 90 degrees minus alpha. And again, angle DOB equals to 90 degrees minus alpha. In the next step, we will do a construction, that is to say, from point P, we will do perpendicular on BD. Again, from point P, we will do perpendicular on BD. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point P and BD. This point is point T. By doing this construction, we get the quadrilateral PCDT. Besides quadrilateral PCDT, this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size because of the fact that those two angles, they are part of square ABCD, and we know that all the angles inside the square are right angles. So those two angles are both right angles, and this is a right angle according to our construction. So in total, in the small quadrilateral PTDC, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth piece again, the total must equal to 360 degrees. According to the rule, it said that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth piece again must equal to 90 degrees in size. So inside quadrilateral PTDC, we have 4 angles, and therefore you can relate to quadrilateral PTDC is a right angle. The length of side AB is actually 34 plus x. 34 plus x is 34 plus 11, because x is 11. 34 plus 11 is 45. So CD equals to 45 units in its length. But you also know that the opposite sides of Earth, you know that the opposite sides of Earth are equal to each other. So in the small rectangle PCDT, side PT must be equal to the opposite side CD, but CD is 45, therefore the opposite side PT must be also equal to 45 units in its length. By doing this construction, we get the right triangle PQT. This is the right triangle PQT. This right triangle PQT. This is a right angle according to our construction. This angle equals to 90 degrees minus alpha, therefore this first angle must be equal to alpha. According to the sum rule, that said that the sum of the angles in any triangle is equal to 180 degrees. Alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore this first angle must be equal to alpha. So in the next step, we prove that this right triangle PQT can go into this green right triangle DBO according to angle sine angle 1. So it is done. We have to prove that the green triangle OBD can go to this right triangle PQT. So right again, right triangle OBD can go into this right triangle PQT. First of all, those two angles are both equal to alpha and therefore they are equal to each other. So actually this is angle BDO in the again right triangle OBD, and it is equal to this angle, this is angle QPT. This right triangle PQT. Because again, if I found out that angle BDO in the green right triangle OBD equals to angle QPT in the right triangle PQT, they are both equal to alpha and therefore they are equal to each other. BD is one side of square ABCD, therefore it is equal to 45 units in itself. BD equals to 36 plus y. Y is 9, so 36 plus 9 is 45. BD equals to 45 units in itself. And therefore, side BD of this grand right triangle OBD equals to side PT of this right triangle QPT. BD equals to PT. BD equals to PT. BD equals to PT, they are both equal to 45 degrees in their laps, and therefore they are equal to each other. And finally, those two angles, yep, this is the right angle, and also this is the right angle. Those two angles are both equal to 90 degrees in their sizes, and therefore they are equal to each other. So actually, this is angle OBD. The again right angle OBD, and it is equal to this angle, the angle QTP. In the right angle PQT. And again, into that, we found out that angle OBD in the right triangle OBD equals to angle QTP in the right triangle PQT. They are both equal to 90 degrees and therefore they are equal to each other. So in total, we found out that the right triangle OBD can go into this right triangle PQT according to angle side angle rule. So now the right triangle OBD convert, this is the sign of convert, to the right triangle PQT according to angle side angle rule. What is angle side angle rule? We found out that those two angles and the side that is included between those two angles, that is side BD, on this green right triangle OBD, are correspondingly equal to those two angles and the side that is included between those two angles is actually side PT on this right triangle PQT. And therefore, those two right triangles can go into each other according to angle side angle rule. Okay, again, we have those two angles and the side that is included between those two angles in this right triangle corresponding equal to those two angles and the side that is included between those two angles in this triangle PQT. Therefore, those two right triangles can go into each other according to angle side angle rule. From the fact that those two right triangles can go into each other, we will know that their corresponding sides must be also equal to each other in their lengths. According to all the corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore their corresponding sides must be also equal to each other in their lengths. the hypotenuse of this main right triangle OBD is OD. So the hypotenuse OD is definitely the corresponding side of the hypotenuse of this triangle QVT. The hypotenuse of this triangle PQT is PQ. This is the last segment that we are looking for. Again, OD equals to PQ according to the rule that corresponding sides can go into triangles are equal to each other. Those two right triangles can go into each other, therefore the corresponding sides, that is to say, OD and PQ must be also equal to each other and the next. But we already found out that OD equals to 53. Second idea that OD equals to 53. And for this equation, 53 equals to OD equals to PQ. We derive that PQ must be also equal to 53 units in its length. And again, we found out that the length of tangent PQ is 53 units in its length. So finish to answer the second question. The next step after the lecture, we start with the repetition of the first question and then repeat on the solution of this second question. In the first question, our test is to find out the length of AB, that is the height of this right triangle BC. If the base is BC, then the height is AB. So we have to find out the height AB of this right triangle BC. So in the drawing, we have a circle that is described by this right triangle BC. So this is the right triangle. We know that BC equals to 40 units in its length, and the radius of this circle equals to 4 units in its length. Again, our task is to find out the height AB of this triangle ABC. So first of all, we define the relevant points to this question with letters. We define the center of this circle, this point is point O. Likewise, we define the point of tendency of tangent AB with this circle, this point is point F. We define the point of tendency of tangent BC with this circle, this point is point E. And finally, we define the point of tendency of tangent AC with this circle, this point is point G. The next step, we join points O and E together by a straight line. Point O is the center of this circle, point E is the point of the circle itself, therefore O is the radius of this circle, that equals to 4 according to what is given as a question. The radius of OE is equals to 4, the radius of OE is drawn to point E, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and F together by straight line. OF is of course the radius of this circle, equals to 4 according to what is given as the question. The radius of OF is equals to 4, the radius of OF is drawn to point F, that is the point of tendency of tangent AB with this circle. Whenever you have this that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius FO. If AB is perpendicular to FO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule 1. So in total, inside the small quadrangle FOEB, we have 2 triangles. The sum of triangles is 270 degrees, so 270 degrees plus the size of this 4 triangles, in total must be equal to 360 degrees, according to the rule that says that the sum of the areas in any quadrangle is equal to 360 degrees. Therefore, this 4 triangles must be equal to 90 degrees in its size. So inside the quadrangle FOEB, we have 4 triangles, therefore we can relate to quadrangle FOEB as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle FOEB, side FO must be equal to the opposite side BE. But FO is 4, therefore BE must be also equal to 4 units in its length. Likewise, according to the sum rule, in the same small rectangle FOEB, side OE must be equal to the opposite side FB. But OE is 4, therefore the opposite side FB must be also equal to 4 units in the step. So in total, we actually found out that quadrangle FOEB is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other, its sides are equal to 4. So we can implement also rule 2. But before that, what is the length of EC? EC in total equals to BC must be. EC equals to BC must be. So EC in total equals to BC, that is 40, must be, that is 4. 40 minus 4 is 36. So in total EC equals to 36 units in its length. So here we can implement also rule 2. We implemented rule 2. Now we're going, and then we can rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing, you have a circle. This is a common standpoint, point P. From this common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can implement rule 2 in our drawing. We focus on this common standpoint, point C. From this common standpoint, point C, we have two tangents to this circle, tangent CE and tangent CG. And according to rule 2, they are equal to each other. That is to say, CE equals to G, CE equals to CG. But C is 36, therefore CG must be also equal to 36 units in its length. Likewise, from this common standpoint, point A, we have two tangents to this circle, tangent AF and tangent AG. And according to rule 2, they are equal to each other. That is to say, AF equals to AG. So if we define the length of AF as X, then AG must be also equal to X. And finally, we implemented the Pythagoras theorem on this big right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle ABC, the hypotenuse is AC, so AC square equals to AB square plus BC square. This again, the right triangle ABC according to the Pythagoras theorem. Here by PT is a version from Pythagoras theorem. According to the Pythagoras theorem, AC squared, that is the square of the hypotenuse, equals to AB square plus BC square. AC is 36 plus X, therefore AC square is 36 plus X square equals to AB square. AB is X plus 4, therefore AB square is X plus 4 square, plus BC square. BC is 40, therefore BC square is 40 square, that is 1600. In total, we found out that X plus 36 square equals to X plus 4 square plus 1600. Here we open the brackets on both sides of this equation, and we found out that X plus 36 square equals to X square plus 36 square, that is 1296, plus 2 times X times 36, that is 72X. On the other side of the equation, we have X plus 4 square. X plus 4 square equals to X square plus 4 square, that is 16, plus 2 times X times 4, that is 8X, plus 1600. We have X square on both sides of this equation, so X square will get cancelled. After we cancel X square on this side of the equation, we have only with 1296 plus 72X equals to, and on the other side of the equation, we have 16 plus 1616 plus 8 square. So we found out that 1296 plus 72X equals to 1616 plus 8X. So here we substituted we substituted 8X from this equation. So here we have 1296 and 72X minus 8X is 64X, and it's equals to 1616. 8X minus 8X is 0. So total we found out that 1296 plus 64X equals to 1616. Here we substituted 1296 from this equation, and we found out that 64X equals to 1616 minus 1296 is 320. So 64X equals to 320. Here we divided the equation by 64, and we found out that X equals to 320 over 64 is 5. So X equals to 5 minutes in its length. Our test was to find out the length of this side AB. That is the height. AB in total equals to AF plus FB. AB in total equals to AF plus FB. AF is X, FB is 4. AF is X, FB is 4, so AB in total equals to X plus 4. X is 5, so AB equals to 5 plus 4, that is 9. In total, we actually found out that AB equals to 9 units in its length. So we finished to repeat on the first question. In the next step, I'll repeat on the solution of the second question. In the second question, our test was to find out the area of this square ABCD and also to find out the length of this tangent QP. So in the drawing, we have a semicircle and a quarter circle inside this square ABCD. This is tangent QP, that is tangent to both the semicircle and the quarter circle at this point. Again, we have two tasks. The first task is to find out the area of this square ABCD, and the second task is to find out the length of this tangent QP. So first of all, we also know that the radius of this semicircle is 17, the radius of this quarter circle is 36. Again, we have two tasks to find out the area of this square ABCD and to find out the length of this tangent QP. So first of all, we define the relevant points to this question with letters. We define this point Z. We define also the length of this short line segment ZB as X. We define this point as point L. We define the length of this short line segment BL as Y. We know that DL is the radius of this quarter circle that is equal to 36 according to what is given in the question. Likewise, the radius of the semicircle AO is 17, OZ is also 17. So we have to find out, first of all, the area of this square ABCD. We know that the area of any square equals to the length of one side squared. Therefore, we choose side AB is the length. Therefore, the area of this square ABCD must be equal to AB square. The area of square ABCD must be equal to AB square. But what is the value of AB? AB in total equals to 17 plus 17 is 34 plus X. AB equals to 34 plus X. Therefore, AB square must be equal to 34 plus X square. So in total, according to equation 1, the area of square ABCD, that is the area that we are looking for in this equation, equals to 34 plus X square. The next step, we choose side BD is the length of square ABCD. Therefore, the area of square ABCD must be equal to BD square. The area of square ABCD equals to BD square. What is the length of BD? BD in total it is 36 plus Y. 36 plus Y, therefore BD square must be equal to 36 plus Y square. So according to the second equation, we found out that the area of the same square ABCD equals to Y plus 36 square, while according to equation 1, the area of the square ABCD equals to 34 plus X square. So we have two equations, equation 1 and equation 2 for the area of square ABCD. Therefore, we created equation 3 that states that the area of square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. Very simple equation. The area of square ABCD according to the first method of calculation equals to 34 plus X square. And it must be equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the second method of calculation equals to Y plus 36 square. So in total, according to equation 3, we have found out that 34 plus X square equals to Y plus 36X. Y plus 36 square. 34 plus X square equals to Y plus 36 square. Here we took out of this equation. Here the square cancels the root and we left only 34 plus X. Likewise, here the square cancels the root and we left only with Y plus 36. So in total, we actually found out that 34 plus X equals to Y plus 36. Here subtract the 34 from this equation, so here 34 gets cancelled. We left only with X in this side of the equation, while on the other side of the equation we have 36 plus 44 is 2. So in this side of the equation we left only with Y plus 2. So in total, according to equation 2, according to equation 3, we found out that X equals to Y plus 2. The next step, implement rule 2 or rule 10 in our drawing. Repeat quickly on rule 10. According to rule 10, if two circles, it could be two circles or two quarter circles, it doesn't matter. If two circles touch each other externally, then the straight line that connects the circles together passes through their touching point. In the drawing, you have those two circles that touch each other externally. This point P. The center of this circle is at point O. The center of this circle is at point O. The straight line that connects the circles together is of course the straight line OM. According to this rule 10, the straight line OM must pass for point P. That is the touching point. Again, the straight line OM must pass for their touching point. That is actually point P. OPM is one straight line. Again, OPM is one straight line according to this rule 10. If OPM is one straight line, it means that OM in total must be equal to OP plus PM. So we can implement rule 10 in our drawing. Because in our drawing, the semicircle touches the quarter circle at this point K. According to rule 10, the center of this semicircle is at point O. The center of this quarter circle is here at point D. The straight line that connects the circles together is of course the straight line OD. According to rule 10, the straight line OD must pass for point K. Or OKD is one straight line. If OKD is one straight line, it means that OD in total must be equal to OK, the radius of the semicircle that is 17, plus KD, that is the radius of this quarter circle, that is 36. So OD in total equals to 17 plus 36, that is 53. OD equals to 53, everything is same. So the opposite of this great triangle OBD is OD, that is 53. In the next step, we implement the Quadratic theorem on this great triangle OBD. According to the Quadratic theorem, in a triangle, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. That is to say, OD square equals to OB square plus BD square. The right triangle OBD, the right great triangle OBD, according to the Quadratic theorem, OD square, that is the square of the hypotenuse, equals to OB square plus BD square. OD is 53, therefore OD square is 53 squared, that is 2809, and it equals to OB square. OB is x plus 17, therefore OB square is x plus 17 square, plus BD square. BD in total is 36 plus y, therefore BD square is 36 plus y square. So in total, we found out that 2809 equals to x plus 17 square plus x plus 36 square. Here we opened the brackets. But before that, we only found out that x equals to y plus 2. So we can substitute x by y plus 2. So it is x is y plus 2 plus 17. 17 plus 2 is 19, so in total we have here y plus 19 square. So y plus 19 square equals to y plus 36 square. Here we open the brackets of this equation, and we found out that 2809 equals to y plus 19 square. Y plus 19 square equals to y square plus 19 square, that is 361, plus 2 times y times 19, that is 38y. Here we also y plus 36 square. Y plus 36 square equals to y square plus 36 square, that is 1296, plus 2 times y times 36, that is 72y. So in total, we found out that 2809 equals to y square plus y square is 2y square. We have 361 plus 1296 is 1657. 38y plus 72y is 110y. So in total we actually found out that 2809 equals to 2y square plus 1657 plus 110y. Here we subtracted 2809 from this equation, so in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 2y squared plus 110y minus 1657 minus 2809 equals to minus 1152. So in total we found out that 0 equals to 2y squared plus 110y minus 1152. Here we divided this equation by 2, and found out that 2y squared over 2 is y squared, minus 100 plus 110y over 2 is 55y, and minus 152 over 2 is minus 576. 0 over 2 is 0. So in total, we found out that y squared plus 55y minus 576 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. This general formula for a quadratic equation, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, to the following general formula. x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0. Now a specific quadratic equation, the variable that we are looking for is y, so x equals to y. The coefficient a equals to 1, the coefficient b equals to 55, and finally the coefficient c equals to minus 576. So we have all the data that is needed in order to find out the value of y. Just have to put this data inside this general formula for x. And this way we find out the value of the values of y, because y might have two solutions. We did it, and we found out that x equals to minus b. First of all, the variable that we are looking for is y, so we substitute x by y, and it's equals to minus b. B is 55, therefore minus b is minus 55, plus minus square root of b squared. B is 55, therefore b squared is 55 squared, minus 4 times a is minus 4 times a, it's 1, so it is minus 4 times 1, that is minus 4, times c. C is minus 576, so in total we have here minus 4 times minus 576, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So total we should find out that y equals to minus 576 plus minus 15 square is 3025 plus minus 4 times minus 576 is plus 2304. So in total inside the root we have 3025 plus 2304 divided by 2. So in total we should find out that y equals to minus 55 plus minus 3025 plus 2304 equals to 5329 divided by 2. The square root of 5329 is 73. So in total we found out that y equals to minus 55 plus minus 73 over 2. So y equals to minus 55 plus 73. The first solution is minus 55 plus 73 over 2. Minus 55 plus 73 is 18. 18 over 2 is 9. So in total we found out that y equals to 9. And we only found out that x equals to y plus 2. That is to say x equals to y, that is 9 plus 2. So x equals to 9 plus 2, that is 11. So in total we found out that y equals to 9 and x equals to 11. The second solution is an incorrect solution because of the fact that the second solution gives us a negative number, y itself must be a positive number. So the second solution is an incorrect solution. So we take into account only this solution, y equals to 9 and x equals to 11. Okay, our test, the first test was to find out the of this square ABCD. The of square ABCD equals to AB squared. AB in total is 34 plus x. Therefore, AB squared is 34 plus x squared. The of square ABCD equals to AB squared, that is 34 plus x squared. X is 11, so 34 plus x is 34 plus 11 squared. 34 plus 11 is 45, so it is 45 squared. 45 squared is 2025. So if you found out that the area of square ABCD, that is the area that we are looking for in this question, in total it equals to 2025 square inches in size. What is the length of tangent? The second test is to find out the length of tangent QP. In order to find out the length of tangent QP, first of all we define this angle ODB is alpha, and so in the green triangle OBD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. We have tangent PQ, is tangent to the quarter second point K. The radius dk of this quarter second is equals to 36. The radius of decay is 1 to point K. That is the point of tendency PQ this second, this quarter second. Remember, this is 1 to the point of tendency, then PQ will be perpendicular to the radius KD. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So in this green small right angle QKD, this angle equals to alpha. This angle equals to 90 degrees according to rule 1. Therefore, this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. 90 degrees minus 90 degrees is equal to 180 degrees. That is the sum of the angles in an triangle. Therefore, this angle must be equal to 90 degrees minus alpha. In the next step, we did the construction, that is to say, from point P, we do perpendicular on BD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and BD. This point is point T. By doing this construction, we get the small quadrilateral PTDC. Beside the small quadrilateral PTDC, those two angles are both right angles because of the fact that those two angles are the two angles of square ABCD. You know that all the angles inside the square are right angles, so those two angles are right angles. This is a right angle according to our construction. So in total, inside the small quadrilateral PTDC, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees. 270 degrees plus the size of this fourth angle, in total is equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this fourth angle must be equal to 90 degrees in size. Therefore, inside quadrilateral PTDC we have 4 angles. Therefore, inside quadrilateral PTDC we have 4 angles. Therefore, we can relate to quadrilateral PTDC as a triangle. CD is one side of square ABCD. CD equals to 34 plus x. X is 11. So 34 plus 11 is 45. So CD equals to 45 in itself. It is one side of square ABCD. We know that in rectangle PTDC, the opposite angles and the opposite sides are equal to each other. So CD equals to PT, but CD is 45, therefore PT must be also equal to 45 units in itself. Likewise, BD is also one side of square ABCD, this is 45. So here we have in this right angle PQD, we have this angle, this is equal to 90 degrees minus alpha. This is a right angle, therefore this angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in the triangle. Therefore, this angle must be equal to alpha. So the next step, we prove that this right triangle PQT can go into this right triangle OBD according to angle side angle rule. So why the right triangle OBD can go into this right triangle PQT? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, BD in the green triangle equals to PT in this triangle QPT. They are both equal to 45 degrees, and therefore they are equal to each other. So in total, we found out that the green triangle BD can go into this triangle QPT according to angle side angle rule. We have those two angles, and the side that is included between those two angles, that is side BD on this green triangle OBD, corresponding equal to those two angles, and the side that is included between those two angles, that is actually side PT, this angle triangle PQT. Therefore, those two angles can go into each other according to angle side angle rule. Again, we have those two angles, and the side that is included between those two angles in this green triangle corresponding equal to those two angles. The side is included between those two angles in this triangle QPT. Therefore, those two angles can go into each other according to angle side angle rule. Again, let's find out that the green triangle OBD can go. This is the same congruent to the triangle QPT according to angle side angle rule. And from the fact that those two triangles can go into each other, the green triangle OBD, the triangle QPT can go into each other, we will have that the corresponding sides must be also equal to each other in the next. According to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, and therefore the corresponding sides must be also equal to each other in the next. The corresponding side of the opposite OD of this green triangle OBD is definitely QP, that is the opposite of this right angle QPT. The hypotenuse of those two congruent angles are the corresponding sides. Therefore, they must be equal to each other. They must be equal to each other in the rest. That is to say, the hypotenuse OD of the green angle OBD must be equal to the hypotenuse QP of this angle QPT. And OP equals to PQ according to the rule that corresponding sides and congruent angles are equal to each other. But we already found out that OD equals to 53. You can write here that OD equals to 53. And from this equation, 53 equals to OD equals to PQ. We have that PQ must be also equal to 53 units in its length. So in total, we found out that PQ equals to the hypotenuse PQ and the tangent QP equals to 53 units in its length. And there of this square ABCD is equal to 2025 square units in size. Okay, thank you very much.